Welcome to our channel. In this session, we are going to discuss about single source shortest path algorithm by using greedy approach. Here, the greedy approach means the algorithm name is Dijkastra'S algorithm. Here, what is the aim of this single source shortest path? In the given graph, you consider one vertex as the source vertex. That is your wish. Suppose for this graph, assume I am consider one as the source vertex. What is our aim? You need to identify the shortest path from 1 to 2, 1 to 3, 1 to 5, 1 to 4. You got it? Identification of shortest path from one source vertex to remaining all other vertices in the given graph. That is the aim of single source shortest path problem. Here, how do we identify? One simple formula is assume V W. If suppose V is the source vertex, W is the destination vertex. V to W. If you have a direct path and if the path cost is very low, this is the shortest path. Or for reaching W, if you have any intermediate, not only one, if you have any intermediate nodes, you can move V to U and U to W. Means the aim is from source to destination. If you have multiple paths are also there with some intermediates, you need to identify the path with shortest distance. Now, what is the formulas? DIST, the term I am using, DIST of W means here the meaning is the distance from V to W. Always remember. Suppose DIST of 4 means 1 to 4. The term represents the distance from source vertex to that vertex is equal to minimum of. Why we are using minimum? You can have either direct path or through intermediate. So what is the direct path? Distance of W or V to U. W is from V to U, U to W. V to U is represented as DIST of U. For any vertex from the source vertex, what is the meaning? Here the meaning is this is the distance from V to U plus here U to W cost, that is not represented in this formula. The U to W cost is from this graph. So that is represented as cost of U comma W. Cost of U comma W. This is the formula for calculating the shortest distance. Clear? Now here you can apply this in the tabular format or you can do in a step-by-step manner. Now, what is the vertex that is completed? What are the different vertices? V is equal to 1, V is equal to 2, V is equal to 3, vertex V is equal to 4, V is equal to 5. Now each iteration, that vertex we are choosing. The vertex, whatever we are choosing. Initially, there is no vertex. Write down 1 to 1. No need to calculate. Why? Because 1 is the source vertex. Now, 1 to 2. What is the cost? 20, comma 1. Here means 20 is the distance from 1. For my easy understanding, I used the path. That is source also from where you are reaching to. For vertex 3, there is a direct edge? No. If there is no direct edge, write infinity. If there is a direct edge, write the corresponding weight. V24, yes, V24 direct edge is there 40, comma, from 1. V25 direct edge is there 110, comma, 1. Clear? This is the first step. What is the first step? The direct distance from source to corresponding vertex. If the edge is present, write down the corresponding weight. If the edge is not present, mark it as infinity. Now, what is mean by this chosen vertex? In each and every step, you need to identify the vertex which has least weight or least cost. Here 20, infinity, 40, 110. Which one you are selecting? You are selecting 20. Now what is my chosen vertex? My chosen, sorry, 1. Cost is 20. The chosen vertex is vertex number 2. Already 1 is the source vertex. Here we are selecting vertex number 2. Now the next step, here 1 comma 2. Anyway, 1 is chosen my permanent vertex. 1 comma 2. For this you no need to calculate. For this also, why? If you are selecting one vertex means from the source vertex to that vertex we are identify the shortest distance. So for vertex 2, 1 to 2, the shortest distance is 20, that is fixed. Now vertex 3. What is your aim? You need to identify the distance from 2 to 3. What is 2 to 3? 60. Here you are writing 60? No. Observe the formula. I will write down this one. What is the meaning? Distance of 3 is equal to minimum of distance of 3. Here this distance of 3 means source vertex to W. What is the source vertex? 1 to 3. The distance is infinity, comma, distance of U means here this is 1, this is 3, 2 is my intermediate node. Up to 2, what is the cost? Up to 2, the cost is 20 plus 2 to 3. 2 to 3, the cost is 60. Now what is the minimum value? 80. So here you are updating 80. It is from vertex number 2. You got it? This is the way you are following. So first to direct distance, in the next iteration one intermediate. If it is not possible in the next iteration another intermediate. Anyway, check. Now 2 to 4. 2 to 4. Is any edge is there? No. Even though if you want, you can write the formula also. That is not a problem. See, distance of 4 is equal to, you can write each and every formula. What is distance of 4? 40 plus up to 2, the cost is 20. Now 2 to 4, there is no edge. If there is no edge, infinity. What is the cost? 40 only. That is whatever it is available previously, that is only. From 2 you are not updating. Now distance of 5. Here the direct cost 110. Up to 2 the cost is 20. Now 2 to 5. This is 2. This is 5. There is no edge. If there is no edge, what is 110? So 110 comma 1 only. Clear? This is my second step, that is by considering 2 as the intermediate. Now what is the procedure? Among all these vertices, identify the vertex with minimum cost. That is this one. I am selecting this one. What is the vertex number? 4. Now 1 comma 2 comma 4. Here for 1 to 1 no need, 2 to 2 no need. This is also no need. Once you are selecting one vertex means for that vertex the shortest path is identified. Now 3. Again I will write down distance of 3 is equal to, distance of 3 is equal to, what is the distance up to now? My distance is 80 or 80. This is from vertex 2. This is from vertex 2. Now you can calculate 4 to 3 also. Where is here? 4 to 3. The cost is 30. The cost is 30. Up to 4, the cost is 40. Up to 4, the cost is 40. And 4 to 3, the cost is 30. Now what is the minimum value? 70. Now the value is 70, which is from 4. You got the point? Previously 80 is by considering 2 as the intermediate vertex. Now in this, if you are considering 4 as the intermediate vertex, see, this is the previous cost. Now 40, what is 40? Up to 4. Now plus 4 to 3, the cost is 30. Now 70, this value is updated to 70, which is from 4. Which is from 4. Similarly, distance of 5 is equal to, up to this step the cost is 110. Now up to 4 the cost is 40. 4 to 5, what is the cost? 4 to 5, the cost is 70. So here this is 110. This is also 110. Which one you consider? Not a problem. With intermediate also that is 110. Without intermediate also the cost is 110. So 110, no need to update also. No need to update the value also. Now in this, what is the vertex you are selecting? You are selecting vertex number 3. So 1, 2, 4, 3. This completed. Now calculate 5. So the previous value is 110. Up to 3, what is the cost? 70 plus 3 to 5. Any edge is there? Yes. 3 to 5, when edge is there, that is 20. Now what is the minimum one? 90. So updated 90 comma 3. 90, that is from vertex number 3. Now only one vertex is available, that is 5. That is also selected. 1, 2, 4, 3, 5. Now all the vertices are selected. Finally, what is the shortest path? Here this, from this diagram only we are observing the shortest paths are 1 to 2. 1 to 1, no problem. 1 to 2 with a value 20. Now what is 1 to 3 shortest path? 1 to 3 shortest path here. Up to 4. 4 is available from 1. Means 1 to 4. 4 to 3. This is the shortest path. If you have doubt, check. 1 to 4, 40. 40 to 3, 40 plus 30, 70. This is the shortest path. Now for vertex number 4, directly from 1 to 4, the shortest path is 40. For vertex 3, that is 3 is from 4. So internal links 1 to 4, 4 to 3, 3 to 5, and the shortest value is 90. These are the single source shortest path problem. Okay. The next session we will discuss one more example. Thank you.